Hello, today we're looking at the quotient rule of differentiation. So let's start by writing out the quotient rules. Let's go scroll over to the right and let's write out the quotient rule. So for given a function capital F of x and it equals little f of x over g of x, our quotient rule tells us that the derivative of capital F of x equals derivative of little f of x times g of x minus little f of x times g prime of x all over the square of g of x. So this is our quotient rule, and we're going to apply that today. So let's go back over to our exercise. We're asked to differentiate the following. Big surprise. Okay, so let's do it. So again, I've noticed all my exercises start with little f of x. So okay, that's fine. Why don't we call this g of x over h of x? Okay, so now we'll write out little f of x equals, we'll write out the quotient rule once, so that you get a feel for it. So little f prime of x is g prime of x times h of x minus g of x times h prime of x all over h squared x. Let's start plugging things in. So g prime of x is 1 minus x plus 2 times h prime, which is 3x squared, all over h squared, which is x cubed plus 1, all squared. And again, we can simplify. There's not a lot of value to simplifying if you're not asked to, but let's do this one. Let's expand out everything in the numerator. Minus 6x squared. Now, I wouldn't advise expanding out the denominator unless you see that you can factor something out, but in this case, just leave it as is. I think it's wisest. So now we have negative 2x cubed in the numerator minus 6x squared plus 1 all over x cubed plus 1 all squared. Just squeeze that in. Great. Okay, let's try a couple more. So our next function is g of x. We got g of x now is x plus 4 minus x squared all over square root of x cubed minus 1. All right, so let's call the top function f, bottom function h, and we're going to take the derivative. So g prime equals derivative of top function 1 minus, again, mess of this here. Okay, 1 minus 2x times bottom function, denominator, minus numerator, times derivative of denominator, so a half x cubed minus 1, the negative half, times 3x squared, all over the square of the denominator. So when you take the square of a square root disappears. Good. All right, let's leave it at that. Looks a bit messy. Okay, well, let's simplify it. Why not? We got a bit of time. Okay, so what's the best way to do this? We can't do much with the square root, so we got to leave them as is. There may not be a whole lot that we can do to simplify. We can multiply the 3x squared into this first bracket, so then we get 3x to the power of 3 plus 12x squared minus 3x to the power 4. And all of this is over 2 square root of x cubed minus 1. And all of this is over x cubed minus 1. Okay, kind of see what's going on here. We need to put everything over a common denominator, at least in the numerator. So why don't we do that? So we're going to multiply this first term, which is actually a fraction over 1, by the denominator in the second term. And this is all in the numerator. So 2 times 1 minus 2x times, actually x cubed minus 1, because the square root of x cubed minus 1 times the square root of x cubed minus 1 is just x cubed minus 1. It's a mouthful. Minus, in brackets, 3x cubed plus 12x squared minus 3x to the power 4 all over 2 times the square root of x cubed minus 1. And all of this is just the numerator, over x cubed minus 1. All right. So, okay, we have room just for the last line. We can take this denominator, 2 times the square root of x cubed minus 1, and move it into the denominator. So we have 2 times x cubed minus 1 to the 3/2, all of that over this big mess, which I will just leave as is. 2 times 1 minus 2x times x cubed minus 1 minus, can we factor anything out? No, let's just leave it. Minus, in brackets, 3x cubed plus 12x squared minus 3x to the power 4. Good. Okay, let's use the quotient rule again. So this one looks interesting. So our function is y equals x to the power 4 plus x cubed plus x squared plus x plus 1 all over 1 plus x squared plus x cubed. All right, derivative of the numerator, 4x cubed plus 3x squared plus 2x plus 1 times 1 plus x squared plus x cubed. All right, let's see if we can reduce this a little bit so we have some more space. Minus the numerator, and just write our numerator out, times the derivative of our denominator, 1 plus 2x plus 3x squared. Good, all over the denominator squared. 1 plus x squared plus x cubed, all squared. All right, so I'll leave that as an exercise for you to simplify. It looks like it could be fun. All right. Whoops, we lost the last question. All right, and finally, f of x equals e to the 3x plus 4 all over 2x squared plus 1. So we have g of x. So we have an exponential function here. So if you haven't seen that before, let's just put that off to the side. You will. Derivative of the exponential, capital F of x is our exponential function. The derivative is just the function itself. So in this case, we have to use the chain rule. So for example, if our function is e to the gx, then the derivative is, let's give ourselves a bit more space, e to the gx, again, times g prime of x. So we have to use our chain rule. All right, so let's just go back to our problem. And we'll need to use this fact that I outlined here on the right. We'll need to use that. So f prime of x equals derivative of numerator. So the derivative of the numerator is this e to the 3x times 3. Okay, so let's put everything in brackets, make it clear. Times our denominator, 2x squared plus x, minus our numerator, let's hope we have space for it, times the derivative of our denominator, 4x plus 1, all over the denominator squared. All right, so let's clean it up a little bit. What can we do here? Well, we can actually factor in e to the power 3. So let's do this. 3e to the power 3x times 2. Sorry about that. Okay. So I brought the 3 out to the front. We have e to the power 3x. We have a factor of x in this term. So let's take that. And then we're left with 2x plus 1 minus. So this e to the 3x plus 4 can be written as e to the 3x times e to the 4. This is due to one of those properties of exponents. Okay, so let me just write over here the property of exponent that we use, for example, if our base is a and it's raised to the exponent m, multiplied by a, same base, raised to the exponent m. This now equals a n plus m. So you can go in either direction. That's exactly what I did for e raised to the power 3x plus 4. Okay, so now all of this is over 2x squared plus x all squared. So now you can see this common factor of e to the power 3x. And we can factor that out. May or may not be worthwhile, but why not? Good, and our denominator stays the same. Good. Well, again, if you're not asked to simplify, I recommend you do not simplify. So that brings us to the end of our session on the quotient rule of differentiation. So if you have any questions, send us a note at info@raisemymarks.com or give us a call day or evening, and we'll be happy to answer your questions. Thank you for watching, and we look forward to seeing you soon.